All right, problem 1-129. Graph the function f of x equals x squared minus 3. Identify the domain and range and identify any special points such as the intercepts and vertex. All right, our function f of x equals x squared minus 3. So this is going to be taking our parabola and it should be shifting it down 3 units. This is our parent function. If you want to go ahead and set up a little table for yourself, if you're not sure where to graph it, eventually, when you're in this course, you're going to learn how to graph it without having to do all this. But we have no b term, and remember the axis of symmetry, the AOS, is going to be x equals negative b over 2 times a. Well, in this case, b is equal to 0, so we know that our axis of symmetry is going to be where x is 0. So it's going to run right along the y-axis here, which makes it pretty easy for us. So I'm going to go ahead and choose a couple values on either side, -1, -2, -3, and let's do 1, 2, and 3 on the other side. So to come up with our y values, let's just go ahead here and substitute values into our function. We're going to do, let's say, f of -3 should be equal to -3 squared minus 3. -3 squared is 9. 9 minus 3 is 6. So to the point, -3, 6. -2, throw it in there. -2 squared is 4. 4 minus 3 is 1. -1. -1 squared is 1. Minus 3 is -2. 0 squared is 0. Minus 3 would be -3. And we're going to see here that 1 squared is the same as -1 squared. So we should end up with -2, 1, and 6. Let's go ahead and plot those on here. We're at 0, 1, 2, 3 down here. We're going to go over 1, down 1, 2. Over 1, down 2. And then we've got 2 1s, so over 2, we're up 1. Over 2, up 1. Remember, it's symmetrical. Then we've got 1, 2, 3, 1, 2, 3, 4, 5, 6. And we're 3 across, so 1, 2, 3, and then 1, 2, 3. Should be the same height. So our parabola should go up this direction, and it should go up that direction. There it is. So it says identify the domain and range and identify any special points, such as the intercepts and the vertex. Well, first thing, our domain, since that's what it asks for first, it's going to be all real numbers. So you can use that. You could say negative infinity is less than x, which is less than positive infinity, or interval notation where you have parenthesis, negative infinity, comma, positive infinity, close parenthesis. The range, in this case, our bottom point's at -3 and it goes up forever. So you could say y is greater than or equal to -3, which is the same thing as -3, comma, infinity, or we've got a bracket on this side and a parenthesis on that. There's your domain and range. Now it says identify any special points, such as the intercepts and the vertex. Vertex, really easy. It's the bottom point here. It's the point 0, -3. That is also our y-intercept. Trying to find our x-intercepts, that one is going to require a little bit more work because it doesn't cross at exactly an integer value. So in order to figure it out, let's just do this. We're going to take our y-coordinate on the x-axis, which is 0, and we're going to put it in as our output and solve it. So if we know that we want our f of x to equal 0. And right now, f of x equals x squared minus 3. We're going to substitute this 0 in for f of x. So we have 0 equals x squared minus 3. We add 3 to each side. 3 equals x squared. Then we take the square root of each side. Do that on another color so it kind of stands out what we're doing. So we end up with the absolute value of x equals the square root of 3, in which case we get positive or negative radical 3 is equal to our x value when y is 0. So our x-intercepts are going to be radical 3, comma 0, and negative radical 3, comma 0. And that's it. There's our special points that we're looking for. There's our graph. We've got a table, our equation. Everything is great. This is closure problem 1-129. Hopefully this answered any questions. Make sure that you ask if you still have some. Thanks for watching.